And so judging by the scores, I'd say this one was easier, or at least there was less calculations. With these, sometimes it's harder to make up stuff that you can't just dig through your book or notes or whatever and find something relative. So anyway, our final is going to be kind of, I think, 50-ish questions. I forget the exact details I put on the syllabus, but basically a heavier focus on the last chapter, the stuff that we finish. And today will be the usual, a little on the short side, because all we'll do is I'll cover the answer key and then field questions and talk about the tests or grades if you want. And so it's kind of, this is, what I've done before and kind of the way I like to do it, where after you take a test and we just do a review day like this, you sort of get a week break from the class. Okay, let me move a couple things. All right, this first one, the Lewis structure, nitrogen, right in between carbon and oxygen, has 5 electrons. So obviously B is wrong, C is wrong, D and E, that's pretty easy. Usually the trick one that's in here is where, right, A is obviously correct, but that's implying that you have, right, we have 4 orbitals. And what we've covered so far, we'll see things coming up are going to change, but 2 in the S and 3 separate in the P. So usually the most likely wrong answer with these is where there's 2 together and 1 left alone, which electrons are negatively charged and wouldn't do. So this is sort of the Lewis structure, same information as an orbital diagram, which I think might have been later in the test too. 2, the lattice energy is that positive energy you get back, which is these are from the gas phase, right? So 2 looks like it could be correct, but that's aqueous. A is solid and gas, and that's not how. This is the opposite. That's splitting it apart. That's the opposite. D is the solid going to aqueous, and this stuff is all based on free ions. That way, there's no ion pairing, etc. I don't know if we've covered that, or you'll see it in 162. Anyway, and then E again, solid and gas. So, I mean, if you caught that, then that was fairly easy. 3 is basically asking you about radius interpretation trends, but it's doing it in the form of understanding the lattice energy. So, if you got the one above right, the lattice energy is, if you think about these things as little magnets, the smaller the radius, the higher charge density, if you will, or the closer the 2 magnets can come together. And so lithium, since it's oxygen and 2, you're kind of comparing those 2, right? And lithium is smaller than K is potassium, so you have lithium that greater than potassium, and then rubidium is below potassium, and also oxygen, sulfur is below oxygen. So there's 2 reasons to rank the rubidium sulfide below the potassium oxide. 4, how many of the following bonds are polar? So this means basically for us, if it wasn't the same element, if they were the same element, they're nonpolar. Then basically anything that wasn't carbon hydrogen, so the chlorine, the CH, the HH, and the CC are not going to be polar. And this one asks which are. So the only 2 left are the ON and the SF bond. And so you didn't need to actually pull out the periodic table that had the electronegativity exact values. If you just knew the trend in the carbon hydrogen and any bond that's the same element, and then all the other bonds that followed the electronegativity trend difference. But you could have, had the sheet or pulled it up and double checked, that kind of thing. This one you know, it says draw it. You don't obviously have to. The formal charge on the carbon. We haven't really gotten to acid-base chemistry, but what acid chemistry is, we covered the names and a little bit about it, and saw a little bit of the initial reactions, but hydrogen can't really have much of a formal charge on it unless it's a +1, but then it would be by itself. And if hydrogen has a +1, then there's no electrons around it, whereas this makes more sense to have the 3 carbon-hydrogen bonds, and the hydrogens be the ones that are neutral, and that, you know, since they only have 1 electron anyway, and then the plus charge on the carbon. Basically, you never see any charge on a hydrogen unless it's by itself as H+. Identify the compound with covalent bonding. So another, you know, some of these were, I think, pretty easy. Again, you know, this is sort of OChem, first week of OChem type stuff, right? You don't notice you didn't need a calculator for this test. You won't for OChem. A for 6, that's your classic ionic metal and a non-metal. B is just a metal, piece of metal, like your car keys or something. C is helium, that's a gas. And it is a non-metal, but there's no bonding going on, it's by itself. So the only thing that had covalent means nonmetals and more than 1 element was D. 7, pretty easy. This is similar to what was on the practice exam, right? You just follow the trend. As you go down and to the left, things get bigger because this one asks for the largest. I think what was on the practice exam were these same elements, but it was the smallest, and you worked your way across. 8, again, another pretty easy one. This is just hammering home our idea of the covalent bond that we've covered, where if you think about the nucleus is positively charged and the electrons are negatively charged, and they're in between the 2 nucleus, and so then the positive, negative, positive bond in a row, charges in a row like that, keep the bond together. And then our Lewis structures, we were doing 2 electrons equals a single, 4 a double, 3 a triple. So the more negative charge you have in between the 2 nuclei, the stronger the bond's going to be. So C. 9, which species would you predict to have the smallest radius? So selenium is lower down in the periodic table. These are all group 6. So smallest, you would assume it's the oxygen, one of those 2. Then sulfur's below oxygen, then selenium. Then you need to know what the trend is. And so if it's negatively charged, the radius gets bigger. So, you know, let's say this same question on the final, the biggest one would be E. And then a positive charge means the electrons, whatever number, here it's +2, have left. And so the remaining valence electrons, right? Oxygen has 6, there's 2 gone. That would be that there's 4 valence ones. They feel, there's less shielding by the electrons are gone, and they feel a higher nuclear charge. So C would be the smallest. Shorthand configuration. I think this one might have actually been directly on the worksheet or one of the worksheets or the study guide. You go in the periodic table, find gallium. I forget, well, P1. It's then below aluminum, or one more down, 1, 2, 3. Yeah, it's right below aluminum. So it's in the P block, so you need to end with a P. It's in the 4th period, so you need a 4 and 1 electron. So you could have gotten it from just that, but double checking, right? You need the rest of the electrons till you get there. So 4 is 2, 3d10. (11) Choose the best structure for OCl2. In general, with all these, right, as you they take a similar format, as long as you have straight line, a bond between these two, and then it'll be bent if you have lone pairs there. So 6 electrons for oxygen, 7 for chlorine. So pretty straightforward that the chlorine wants to form 1 bond, oxygen, it's typical, wants to form 2. Then you can start eliminate, knowing that, right? I mean, our right answer's over there with the lone pairs. And this one didn't do anything for the shape, but you can start eliminating these other ones just from too many electrons around the oxygen for A. This is not the typical bonding pattern, right? Oxygen doesn't want to form 3 bonds if it doesn't have to. C has way too many electrons around it. Oxygen, again, it's 2 bonds. Sometimes you'll have the third, but it doesn't want to do that. Same thing with only 1 bond, but it doesn't want to do that. So E is the happy. It takes on those normal bonding modes for all 3 elements. Right, really similar to water, because chlorine is below fluorine, and then, like I pointed out in some periodic tables and some of the stuff we've covered, hydrogen is kind of like a group 7, in the sense that it only wants 1 more electron, thus 1 more bond to fill its orbital. 12, that was a super easy one, I think, for everybody, right? It's electron configuration. It's right there at the top. It's a second element, so 1s2, there's no charge, 2 electrons. 13 is kind of the opposite of the problem above, right? A, B, and D are all non-metals and multiple elements, so they're all covalent compounds, and so C is the classic metal, non-metal. 4, again, similar to the one above, choose the Lewis structure that's best for NH4 plus, right? The plus isn't going to be on any of the hydrogens. I guess here it put it on the outside anyway. It could have asked about the formal charge, but it actually didn't. Let's eliminate nitrogens in group 2, so it can only have 8 electrons around it, so you can just eliminate these ones that it has too many electrons, and just knowing that, the answer is E. And this is, past its normal bonding mode, but this is fairly common for nitrogen to do this. And none of the other options make any sense. So this is one thing you want to get in the habit of for everybody who has to take OChem, is carbon is right next to nitrogen and oxygen on the periodic table. It's in period 2. And it can't have more than 8 electrons around it. So it drives OChem professors nuts, makes them very upset when you have carbon that has 5 bonds, which means 10 electrons around it. All right, 15, free radical. So you needed to know that a free radical means an odd number of electrons. And if you knew that, then this one was pretty easy. H2, right, is 1 electron each, times 2, that's 2. Hydrogen and chlorine, or any other element in group 6, they want to form 1 bond, so 1 plus 7, that's 8. Right, water we've done a bunch of times, oxygen 6, hydrogen's 2, and there's 2 of them, so 8 electrons there, it's fine. Right, and then here you have oxygen and fluorine, so fluorine wants to form 1 bond, oxygen wants to form 2. So you are short an electron, and so an odd number. And so this doesn't really exist. If this thing did exist, it would be a minus you would need, right? Just like the bases and things, we'll see hydroxide coming up in next semester. Then E is just, it happened to be fluorine, but any group 7 element comes this way. And those are the things you had to memorize, right? Or was good to memorize way back when, chapter 4, oxygen, nitrogen, hydrogen, and all of group 7 come as X2 diatomic molecules. 16, it says choose the bond that's most polar, but notice that every possibility here has hydrogen in it. So really, you're just picking the most electronegative atom that hydrogen's being bonded to. And fluorine is the most electronegative atom, so that one was pretty easy. 17, which of the following are paramagnetic? So this was finding their positions on the periodic table. Manganese has no charge, so you don't have to add or subtract anything away. And it's 2, and so it's 2 electrons. 2 are always going to be, they'd always be paired unless there are 2 orbitals, but it's s orbitals. There's only 1. Barium's below magnesium, but those 2 electrons are gone. Molybdenum has s and d electrons, but they're all gone. Sodium only has a 1 s electron, but again, it's gone. Phosphorus here has 5 electrons, but they're saying -3, so add 3, and that gets to the 8. Oxygen, same thing, 6. And they would be unpaired as we've looked at the orbital diagrams up to this point, but -2 means filled. Zirconium has 4 electrons, and so 3 missing leaves 1 electron. Choose the bond that is the weakest. So kind of ties into the problem above. I guess it does. You would just pick it based on single, double, triple. It's sort of the opposite way of asking it. But the other thing too is the length of the bond. So if this carbon oxygen was a single bond, or the nitrogen was a single bond, the answer would still be C, because the longer the bond, the weaker the bond. Again, that's the idea of covalent bonding, is a negative charge in between 2 nuclei that are positively charged. So the further they are away from one another, the weaker the interaction. What's the formal charge on the phosphorus atom in the following compound? H4P2. I'll just pull up the Lewis structure online. Change the share. So this is called diphosphane, but phosphorus is right below nitrogen. So in those common bonding motifs, the lone pairs aren't drawn in here. And again, for people that are going to go take OChem, you won't see lone pairs after the first month or so. Hydrogen only makes 1 bond, and then the phosphorus is doing its normal thing, 3 bonds, just like nitrogen, and then a lone pair, even though the lone pairs aren't drawn here. It happens to take on this shape, but that's not terribly important for what was on our test. So if it's in, back to the question at hand. So if it's in its normal bonding mode, then the formal charge is 0. The other key thing with this is that hydrogen, its formal charge is always going to be, neutral there with the hydrogen, because it only forms 1 bond. And then if it's not forming a bond, then it's H+, it's by itself. So, but again, you'll see that in OChem, in Chem 162. Identify the weakest bond. Looks like this one is P for all of them, so phosphorus, so that makes it basically the same. And then you're basically then just looking, since the dashed line here is implying a single bond, so they're all the same bond, then it's just placed in the periodic table, and this is just going down group 7. So essentially just indirectly asking via bond strength, asking you the radius of these 4 different atoms, and something has to be the weakest bond. So whenever it's something like which is the strongest or weakest or highest or lowest, etc., it's not going to be E, none of the above. 21, which compound has the longest carbon-carbon bond? So this one is pretty similar to others of A is single, B is a double bond between the carbons, and C is a triple. So you had to recognize that from the Lewis structures, from the formulas given, and then what the Lewis structures must be and then knowing, the previous information, right? Single, double, triple. And so the longer the bond, the weaker, and then the more electrons in there, the shorter and stronger the interaction. So kind of lots of things but going on, but asking it indirectly. Here's that ammonium again, and the reason this is in here is you'll see and use this a lot, not only in OChem, but next semester in Chem 162. Again, the charge is never going to be on the hydrogen in any of these Lewis structures. You're never going to put a plus or a minus charge on hydrogen. It only has one electron and shows up with it, so it's seeking one other electron to make the bond. So either the electron's there and it's making the bond, or the hydrogen is there. So there's never going to be a formal charge on the hydrogen for the stuff you'll ever do. I'm sure you could Google search like radical, like crazy. When I say radical, I don't mean like chemical radical, I mean extreme, gas phase reactions where someone might, draw or assume something, but not relevant to what we or you will learn in OChem. 23, pretty easy one here, just knowing the trends. So this is basically opposite of the question above, where you work your way across the periodic table. So the trend is, as you for smallers, you go up, and then that contraction that we saw. So the furthest up and to the right of these choices is E, oxygen. 24, I guess you could have used the calculator for this one. This is just what bonds are breaking and what bonds are forming. So you've got PCl3 here, you form 2 new ones. So you're going to get twice the PCl3. And then you broke the 1 chlorine-chlorine bond. So in general, the only way to make a mistake on this one, I believe, is if you forgot to multiply PCl to 331 by 2. Uh, 25, give the number of valence electrons. So this was just knowing that valence electrons are the S and P. Hydrogen only has 1, and you've got 3 of them. Phosphorus is right below nitrogen, group 5. So 3 plus 5 is 8. And then you've got 4 oxygens. So 4 times 6 is 24, plus 8 is 32. So this one, I guess you could do old school, but I guess, yeah, there was one problem that you needed some way of calculating it. And I don't know if you'll see this in OChem, that bond one, like you won't need a calculator in OChem. But clearly much different than our other exams. And the next chapter will be a lot like this, but the chemical bonding expands even more and explains stuff that beyond what we've covered here, right? So for people that know you got to take OChem, the stuff we've covered so far is a good foundation, but it's really the rest of the last chapter that is critical for organic chemistry. And basically what they'll do is smash and jam it all into like the first 2 days of lecture, reminding you of all these things that we're covering, and then start expanding it going on into much larger OChem concepts. Okay, yeah, I covered them all. So I hit the unmute if you want to ask any questions. Like last times, or like our last 2 exams, I like to give people a day off or a day just to review and not have new concepts. I know you've got other classes and finals and projects and labs and stuff like that. So hang out, ask whatever you want. If you're good, then we'll see you Wednesday, and we'll just be finishing that last chapter. And whenever we finish it, then we'll just be reviewing for the final. So with that, questions, comments, thoughts, feelings.
Can you walk through 24 again? I got it right, but I think I did it wrong.
Products minus reactants. So the bonds you form, you get that energy. So 331 times 2 is negative, right? Because when you get energy, just like remember an exothermic reaction, the heat coming off, like a ball bouncing down a flight of stairs. And then the bond you broke, that took energy. So that one's uphill and is positive then.
All right. Wait, and how many bonds did you break? You broke one
Yes.
and you created two.
Yeah, so for the chlorine, it's just the Cl-Cl, it's a single bond. And the PCLs are single bonds, right? But you have 3 of them here and you have 5 of them there. So 331 times 2 minus 243 gives you 419. But the 419 should be negative, right? So the bonds that you formed, there's more, that's more energy than the bond you broke. So you think about it, like to break the Cl-Cl, that took energy, so you went up 243 units, and then making the PCl twice, you came down 331 units, and then down another 331 units.
Okay, yeah, and you just have to know that it's negative. Your equation will always be positive.
Well, I mean, like I could just take this problem and put it on the final and make PCl5 the reactants and PCl3 plus Cl2 the products, and then the sign would flip.
Yeah,
But
yeah.
you're better off kind of understanding. I mean, you'll only see this. I don't think you'll see this in OChem, maybe, but you probably won't see. You'll see it in one chapter in Chem 162 a little bit. But like think about these like magnets, right? Like when you leave a magnet on your refrigerator, it stays there indefinitely. So that's like a bond, and to break it, you have to pull the magnet off. Now I know it's not much energy, but it's still, you have to put, whenever you put energy in, that's like pushing, the slinky or the ball up to the top of the flight of stairs. And then when it comes down, you get the energy back. So the bonds breaking always take energy, and the bonds forming is always energy coming off. So energy going in is a plus, energy coming out is a minus.
All right. Yeah, that makes sense now. And so I'm trying to, this is a different question. I'm trying to understand what my grade will be or get an estimate. So it's just our grade is based off the 3 exams minus the lowest score and then the final.
Yeah.
And then how much is the final worth? Or are they all worth the same? And it's just
No, the final is going to be worth twice because the test time is twice as long and it'll be comprehensive. It'll focus more, I'd say like 30% or so, maybe, on this last chapter that we'll get to, and then 60 or 70% is review of, so the old exams and the old study guides are good things to study for those. And what you want to make sure, like take a look at your old exams, make sure you want to get stuff you already got right if you see it again on the test, correct, and you want to get stuff that you missed, your second chance at the apple, so to speak. You want to make sure you get, don't miss the same thing twice.
So our total grade will be out of 100.
Yeah,
How
20.
many points?
Yeah, because they're all 25. We drop them, we have no homework, and then 50. Yeah, so when you add those up, that'll be your percent.
All right, thank you. And have a good one.
All right, cool.
Thank you, Professor.
Yeah.
Wednesday. Bye.
Bye. Stop.